Everyone, welcome back to my channel. I am Dr. K. Today we shall be discussing critical angle and total internal reflection. So critical angle and total internal reflection are two things that are closely related. Are you getting it? So now when you are talking of critical angle, what exactly are you talking about? So critical angle is the angle of refraction. It's the angle of incidence when the angle of refraction is 90 degrees. So that's just critical angle. The angle of incidence when the angle of refraction is 90 degrees. So that's it. Now, when you're talking of total internal reflection, So total internal reflection is just a phenomenon in which all the lights are reflected, all the incident lights are reflected. Are you getting what I'm saying? Now, this is it. Total internal reflection occurs when the angle of incidence is above 90 degrees. Are you getting when the angle of incidence is above, I'm sorry, when the angle of incidence is above the critical angle, then you talk of total internal reflection. So you can agree with me that if there is no critical angle, then there can be no total internal reflection. Are you getting it? So total internal reflection takes place when the angle of incidence is above the critical angle. So I'll be showing you some things to you. Now, before we can have critical angle and total internal reflection. Then that means light must be traveling from a denser medium to a less dense medium. So what am I saying? So that's one of the conditions for you to have a critical angle and total internal reflection. So light must be traveling from a denser medium to a less dense medium. So for example, let's say light is traveling, for example, you incident a light through a glass. Are you getting it? So the light is traveling from glass to air. From glass to air. You can see that the glass is denser than air. So it's a more dense medium, while the air is a less dense medium. So that's the case for critical angle and total internal reflection. So that has to be happening. Now, I will show you something. Now, I want you to quickly notice something. When you incident a light, when the light is incident, are you getting it? Some of the rays of light are refracted. We're talking of refraction, that is, they are bent. Are you getting it? They are bent, they are refracted. So the rest will be reflected. Are you getting it? But more of the light is refracted. Are you getting it? More of it is reflected and only few is deflected. So there's a weak reflection. Now let's go. So I will illustrate some things to you now. Please, I want you to stay focused and pay attention. So now let's go. Imagine a scenario where you have a glass. This is a glass now. Now, normally this should be a glass. Let's say we have a rectangular glass. Are you getting it? But for the sake of some angles, I will show you. Now, this is a glass. So this one medium a glass. This is another medium here. So don't forget, here is an empty space. So I will not represent it any. So let's make it an empty space. Are you getting it? So this is a glass. Now, because of the angles I will be showing and some other things, I will have to use a line to represent my glass. Are you getting it? So this is a glass. We have a glass here. So this is a medium. We have an air. Yeah, this is a medium also. So now let's go. Now look at something. There's something we call normal. That's the line passing through the medium. That's normal, a straight line. That's a vertical line. We call it normal. Are you getting it? Now, a ray of light is incident. Are you getting it? Now, this is what you have here. This is an incident ray. This is an incident ray. Now, it's going this way. Are you getting it? I mentioned something the other time that some of the ray will be reflected. Now see. So this is the reflected ray. You can see it going out. So this is the angle of incidence that's represented by I. So this is the angle of reflection. That's R. That's angle of reflection R. So now let's go. Now some of the light will be refracted. That is, it will be bent. Now look at this now. This is the refracted ray. This is the refracted ray here. So look at it. Some of it will come here. So this will be our refracted ray. Are you getting it? So it enters the name of refracted ray. So now I want to establish, how do we get total internal reflection? How do we get it? Now look at something. Imagine a phenomenon where the angle of incidence is adjusted. Are you getting it? It's increased. Are you getting it? It's increased. When the angle of incidence is increased. For example, now look at the angle of incidence here. Let's assume it is 40. Let's assume it's 20 degree. Are you getting it? And you keep on increasing. You keep on increasing it. So let me take this one as my this my x. Let me take this as xy. Are you getting it? So from here, now you keep increasing it. Are you getting it? Now it moved from xy to py. Are you getting it? To py. Now as you keep increasing it, you are bringing it down. So this refracted ray, do you know what's happening to it? It's moving up also. It's moving up also. So this will also move up a bit. So let's say this one, okay, let me take this one as P. So from here to here we have py. So now it will move up also. So P, let me use L here. So ly, it will move up also. So when you adjust again, imagine you adjust again. Let me use what have I used? Okay, I've used P here. Let me use O. So let me use S. So you adjust it, you brought it down a bit. Are you getting it? It will. So this one also will move once more. Are you getting it? So let's take this as S. Are you getting it? So as you are moving this one is moving. As you are moving, this one is moving. So now let me show you. So it gets to a point that your angle of refraction, that the angle of refraction, I should have written angle of refraction here. So it gets to a point that your angle of refraction is 90 degrees. Now let me show that. So I will show you now. Now listen. So when you keep adjusting, So it gets to a point. So this is our incident ray again. So now let me show you. So I want to have not mentioned is that incident ray equals to the refracted ray. So now let's go. Let's assume you have adjusted it. It gets to a point where this one the refracted ray will keep moving. As you are moving, it's moving. And it gets to a point that this will be equal to that the refracted ray will be here. Are you getting it? At that point, don't forget from here to here, this is a straight line. Half of this here we have 90 degrees. Are you getting it? From here to here 90 degrees. So this 90 degrees. So this will be the refracted this will be the refracted ray will be here. Refracted ray will be here. So it's 90 degrees. Now, when the refracted ray is 90 degrees, are you getting it? What do you have? So what we now have is critical angle. See, we have it here. We have it here. Since angle of incidence is equal to angle of reflection, are you getting it? So we have critical angle in both sides. Are you getting what I'm saying? So that's what we call a critical angle. So the critical angle, it is the angle of incidence. Are you getting it? When the angle of refraction is 90 degrees, that is when the angle of refraction is 90 degrees. Now you see, so it has gotten here. The angle of refraction is exactly 90 degrees. Are you getting what I'm saying? So that's it. So now, let's talk about the total internal reflection. When you're talking of total internal reflection, now look from here, we establish what total internal reflection is. So when this angle now, this is the critical angle. Am I right? Let's guess this is the critical angle. Now when you now increase when we make our angle of incidence to be a bit above the critical angle, are you getting it? So imagine we move it to be above critical angle. What you have is this, the refracted ray will no more be here. Are you getting it? Then the refracted ray will disappear. So the ray will come up here. Are you getting it? So when you move this one goes up also. So when it comes up here, what happens is that all the lights are now reflected. Are you getting it? All the lights are now reflected. What you will have now, you will have at this point you are still having a refracted ray. Are you getting it? But when it starts getting, you can see that it has totally gotten even out of the glass medium. Are you getting it? It's now out. So it will now, when you move, it's now out here. Once it's out here, what you have now is total internal reflection. That is internal. That is all the rays are reflected inside the glass. Are you getting it? It will no more come to other. It's no more in the other medium. Total internal reflection. So at that point, when at the point when the angle of incidence is above the critical angle, so we said that light is totally internally reflected. Are you getting it? So that's what happens at that point. Then all we will have is reflected ray. Will not have refracted ray anymore. The light will not be maintained anymore because it's no more in the second medium. It's not in the first medium. So that's when we talk of total internal reflection. So one thing I want you to take note and office. Now, when you're talking of conditions for total internal reflection to occur, the first thing is that light must be traveling from a denser medium, for example, glass, to a less dense medium, in this case here. That's first condition. And another condition for total internal reflection to occur is that the critical angle, the angle of incidence must be above the critical angle. Are you getting? The angle of incidence must be above the critical angle. So what are we saying when you are talking of critical angle? So now the critical angle is whatever angle you get. For example, when the angle of refraction is 90 degrees, for example, if the angle you measure at that point is 50 degrees, that's your critical angle. So when the angle of refraction is 90 degrees, if the angle you measure at that point is 60 degrees, that will be your critical angle for that medium you are using. Are you getting it? So take note of that. So now we have been able to establish that. So I know by now you know what critical angle is. As I've said earlier, the angle of refraction when the angle of incidence is 90 degrees. So you know total internal reflection. So total internal reflection, it occurs when the angle of refraction is above the angle of incidence is above the critical angle. So please take note of that. Now from Snell's law, we have N1 sine I equals to N2 sine R. Are you getting it? N2 sine R, N sine R. So in this case here now, sine of angle of incidence, this is our N1, that's medium 1, in this case glass. Sine of angle of incidence, so in this case that's our critical angle. So you can now write it as N1 sine C equals N2. Then our N2 here is here. Are you getting? That's N2 sine. So our sine here is 90 degrees. Are you getting it? Sine 90 degrees. Our sine R, our R here is 90 degrees. So angle of refraction, that's 90 degrees. So that will be sine 90 degrees. Are you getting it? Now, let me quickly do it here. Now, sine 90 degrees equals 1. So now, what will be our critical angle here? Our critical angle will be, so that will be sine C. I'm coming. Sine C equals N2 over what? N1. We divide by our N1. Sine C equals to it. So since sine 90 degrees is 1, are you getting it? So what you have left is N2. So then we have our N1 here. When you divide by N1, we have N1 sine C over N1. Then our C, that's our critical angle. C equals to arc sine N2 over N1. Are you getting it? So this is the derivation of our C. So thank you for watching the video. Please subscribe and like. God bless you.